question number 26, a block of mass m is released from rest from the position as shown in figure. Friction is absent everywhere. The final velocity of wedge is. So the final velocity of the wedge when the block m reaches to this position, let at this moment it is moving in this direction with velocity v. Then by applying principle of conservation of linear momentum in horizontal direction, we get the velocity of block in this direction is 2v. So if I apply the principle of conservation of mechanical energy, as there is no friction anywhere, so I can write half into 2m into v square, that is the kinetic energy of wedge, plus the kinetic energy of block is half into m into 2v ka square, that is equal to loss in potential energy, that is equal to mg into r. So if I solve this, I get the value of v. So it comes out to be gr by 3. So the velocity of the wedge is under root gr by 3. So option 2 is correct. Let's move to question number 27. In question number 27, two identical blocks A and B connected with a spring are kept at rest on a smooth horizontal surface. A third block C, moving with velocity v0 is equal to 12 meter per second, hits the block A and sticks to it. So the maximum velocity of block A in subsequent motion will be. So the mass of block C and A is same. When it hit the block A and sticks to it, so on applying the principle of conservation of linear momentum, we can say that m into v0 is equal to 2m into v final. So v final comes out to be v0 by 2. So now the block A and C are moving together with velocity v0 by 2. So in the question, it is asked maximum velocity of block A in subsequent motion. So when it starts moving with velocity v0 by 2, then it compresses a spring, due to which spring force will act in this direction, and this spring force retards the velocity of block A and C. So we can say that at this moment the velocity of block A is maximum, so it is v0 by 2. The velocity of v0 is 12, so 12 by 2 is 6 meter per second. So option 1 is correct. So the correct answer for question number 27 is option 1. Let's move to question number 28. In question number 28, a particle starts from rest and moves along a straight line such that its acceleration a as a function of velocity v is given as a is equal to 5 divided by 3v plus 2, where a is in meter per second square and v is in meter per second. The distance travelled by the particle till it attains velocity of 10 meter per second. So we can write acceleration a as v into dv by ds. So it is equal to 5 divided by 3v plus 2. So if I separate the variables, it can be written as 3v square plus 2v into dv. So it is equal to 5 into ds. So if I apply the limit of integration, so when the particle is at rest, I have assumed let it be at origin. So, and when it attains a velocity of 10 meter per second, it has moved a distance s along a straight line. So it is equal to 5 into s, and that is equal to v cube plus v square, and limit of integration is 0 to 10. So on solving this, the value of s comes out to be 220 meter. So option 3 is the correct answer. So the correct answer for question number 28 is option 3. Let's move to question number 29. In question number 29, a circular disc of radius r is removed from a bigger circular disc of radius 2r, having uniform mass density ρ, whose center lies at origin, such that the circumferences of the disc coincides. Now another disc of radius r and density 2ρ is placed in vacant space. The center of mass of the new disc system is at a distance of. Let it is an initial disc of radius 2r. So if I calculate the mass of this disc, it can be written as ρ into pi into 2r whole square. So it is equal to 4 ρ pi r square. So from this disc, a circular disc of radius r is taken out. So there is a circular disc of radius r, and this radius is 2r. Now this vacant space is filled by another circular disc of density 2 rho. So this m dash can be written as 2 rho into pi r square. Now, so on further solving, it comes out to be 2 into rho into pi r square. It means that we have replaced this mass rho into pi r square by 2 times rho pi r square. So the position of the center of mass of the new system is in x direction only because of symmetry. So I can write xcm is equal to complete mass of the disk whose density is rho, that is 4 into rho pi r square, and its center of mass is located at the origin, plus the center of mass of the remaining mass, that is rho into pi r square, lies at a distance r from the origin, divided by total mass, that is 5 times rho pi r square. So on solving, it comes out to be at a distance of r by 5. R by 5 from origin, so option 3 is the correct answer. So the correct answer for question number 29 is option 3. Let's move to question number 30. In question number 30, a bead is at rest at the top of a fixed frictionless hoop of radius r that lies in a vertical plane. The bead is given a small push so that it slides down around the loop. The angle theta made by the bead with the vertical diameter when the acceleration of bead becomes horizontal first time after the push. Let at this moment when the bead is at this position, there is a possibility that the acceleration may be horizontal for the first time. So if I say this angle is phi, then this angle is also phi. So if I see the forces acting on the bead, mg is acting in this direction if m is the mass of the bead. So mg sin phi is acting in this direction, and m into v square by r is the net force acting towards the center on the bead at this moment. So in order to have the horizontal acceleration first time, the vertical acceleration or the forces in the vertical direction must be balanced. So if I take the component of this force in vertical direction, then this angle is also phi. So the component in this direction will be m into v square by r into cos phi. And if I take the component of this force in vertical direction, that will be mg sin phi into this angle is phi, then this angle will be pi by 2 minus phi into cos of pi by 2 minus phi. So again it is sin phi. So these forces must be balanced. So I can write v square by r into cos phi must be equal to g sin square phi. Now I have to calculate what is the value of v square by r. It is given that r is the radius. So if I apply the principle of conservation of mechanical energy at this position and at this position, I can write mgr plus mgr cos phi is equal to half m into v square. So from here I get v square by r is equal to 2 times g into 1 plus cos phi. So if I substitute this value here, I get 2 into g into cos phi into 1 plus cos phi, and that is equal to g into sin square phi. So g cancel out. So on solving this equation, we will get the value of cos phi, and that comes out to be minus 1 and 1 by 3. Since phi is an acute angle, so we can say that this value gets rejected. So the correct value of cos phi is equal to 1 by 3. So if I calculate the angle theta from the vertical, that comes out to be pi minus cos inverse of 1 by 3. So option 2 is the correct answer. By this, I wish you all the best for your preparation. Have a good luck. Thank you.